All right, here we go. Just 1 second, y'all. Let me ask the question and bring on my.
I'm going to tell you never actually went to space. So our Enterprise went 26,000 feet up off the ground. The beginning of space starts at around 380,000 feet. So if our space shuttle went into space, then why was it so important? Well, our space shuttle, the Enterprise, got up in the air thanks to a Boeing 747 space shuttle carrier, and then it was dropped with no fuel in it. And it went from that 26,000 feet up in the air and landed on a runway just like an airplane. And we're going to talk about that more again a little bit later. But for now, how did we get from hitching a ride on the back of an airplane to our launch from a launch pad like our space shuttle Discovery? Well, it takes a little bit of physics and a whole lot of fuel. We're going to start with the physics first. So the physics of a space shuttle launch are thanks to my friend Sir Isaac Newton and his 3 laws of motion. And to talk about them in a more dynamic way, we are going to launch some of our own rockets. So I need some volunteers to do a little rocket launch. All right, you two, my friends, come on up. All right. So I want one of you to stand here, one of you to stand right next to us. Perfect. All right. So I would like you all to wave to your audience. Hello, audience. Yes, hello, audience. Hi. All right. You two are going to tell me, these are our rockets right now on our launch pad. What are our rockets doing right now? Yeah, they're getting ready to take off. Right now, they're sitting on their launch pads doing nothing. And guess what? They will continue doing nothing until we do something to them. That's Newton's first law, the law of inertia. Something at rest will stay at rest. Something in motion will stay in motion unless an outside force acts on it. So let's give it some outside force. I am going to pull back our black plunger here. All right? And something's going to happen. I want you guys to put your hands right over the top there. Give it a little space. Give it a little space, my friend. All right. What do you feel? All right, now you try. What do you feel? Air. Very good. So the force that we are going to apply is air pressure. So when we pull back our plunger, air goes up through this fatter bronze tube into this skinny bronze tube, gets shot out the top into our rocket. How much force we apply is equal to how much air is inside of the fat silver tube times how fast we get it to go with our plunger. All right, so I think we are about ready to launch our rockets. So I want you guys to raise your left hand, and put it on that fat silver tube. All right, now raise your right hand. All right, and you are going to take hold of this black knob, and you are going to pull it back. We're going to give them a countdown to blast off. 5, 4, 3, 2, 1, blast off. And when we hit blast off, you guys are going to let go of that knob. Are you ready? Yes, awesome. 5, 4, 3, 2, 1, blast off. Woohoo! Good job, my friends. Give them a round of applause. You guys can go on down to your seats. Both went pretty hot. So, when our force acted on our rockets went into a particular direction. Can you point to the directions our rockets went? Yeah, they went up. And that's because of our last law of motion. For every action, there is an equal and opposite reaction. So, air pressure went up the skinny prongs tube and into our rocket. Now, our rocket has a clay stopper on the top, so there's only one place that air can escape, and that is out of the bottom. As air escapes out of the bottom, the rocket itself goes up. And that is the little physics about our rocket launch. Now, getting our space shuttle stack into space is a little bit different than launching straw rockets. That's because the space shuttle is a little bit heavier. So our orbiter that you see right over your head on our space shuttle stack weighs 150,000 pounds, or 68,000 kilograms. Inside the orbiter, you can fit 65,000 pounds of stuff. That stuff can be food and water and supplies for people on the International Space Station, or it can be things like the Hubble Space Telescope. That is 30,000 kilograms. This big orange external fuel tank you see on our space shuttle stack, that weighs 1.6 million pounds, or 725,000 kilograms. Each of the pencil-shaped white solid rocket boosters on both sides of the space shuttle stack weigh 1.3 million pounds, or 590,000 kilograms, which gives us a whopping total of 4.4 million pounds, or 2 million kilograms. Our space shuttle stack is one of the heaviest objects human beings have ever tried to shoot off the ground and into space. So, how did we do it? Well, we did it the same way a caveman would. You see, we used fire! Very, very powerful, very, very controlled fire, but fire nonetheless. So, how do you make fire? Go try this at home, kids. First thing you need is a fuel source. In a campfire, the fuel source is wood. In a candle, that fuel source is the wax and the wick. In our rocket, that fuel source is known as propellant. Second thing you need is an oxidant. So here on Earth, we're real lucky. We have our oxidant in the air around us. It's called oxygen. But when you are in space, you're in a vacuum. There is no oxygen, so you have to bring your oxidant with you. The third thing you need is ignition. You need a little bit of a spark to get the whole reaction going. Once you've got these three things put together, you have fire. And because you are here at the Intrepid today, we are going to use these three things to create a spark for you today. So in order to do that, I'm going to put on my safety glasses, because safety first, kids. All right. And I've got two thermite spheres. They're made of steel, but they have been rusted. Rust is called iron oxide, and oxide is going to be our oxidant in our experiment today. They are covered in aluminum foil, and aluminum foil is going to act as our fuel. And I am going to provide an ignition source by bringing these two together on an angle, and we're going to get a little bit of a spark. Are you guys ready? Yeah? All right, let me see if I can do this. Stop hitting my fingers. All right. You guys see that? I'll do it again. Gotta get a good side. So, we've got our fuel, our oxidant, and our ignition source. And that is the same way that we create fire for our space shuttle stack. All right. Now, when a space shuttle lifts off, there are two types of fire that can be seen from underneath it. The first is going to come right into this blue circle. This is a space shuttle main engine fire. And what color is that fire up there? Yeah. Yeah. Blue, very good. It is blue because it is very, very, very hot. It is burning liquid oxygen and hydrogen. Now, oxygen and hydrogen are very interesting because when they burn, they create something extra, something called H2O. What's H2O? Water. Very good. So every space shuttle launch has fire that creates water on a chemical level, and that is awesome. Every space shuttle launch creates about 2,000 pounds of water per second. The second kind of fire is right down here from those white pencil-shaped solid rocket boosters that are on both sides of the space shuttle stack. This solid rocket boosters are burning aluminum, solid aluminum. Not aluminum like aluminum foil that I showed you on our thermite spheres, but this aluminum is more in the consistency of a pencil eraser. And this burn gives us over 2.5 million pounds of thrust. That gets our 4.4 million pound space shuttle stack up off the ground and into space. These solid rocket boosters are some of the most powerful ever used on a space mission. Now, once we get our space shuttle stack up off the ground, we're in the air going through the atmosphere. These white solid rocket boosters only take 2 minutes to go through their fuel. 2 minutes. And when that happens, they fall off. And they fall into
dihydrogen monoxide.
the ocean,
Yeah, you're right.
where they're recovered
Yeah,
and
by the way, the
hopefully
mic can pick us up.
reused and recycled for the next mission. In order to show this, I've got a little bigger rocket launcher with me today.
There no.
And I need a volunteer. My friend in the gray and blue. Yeah, come on up. All right. So with my straws, I want you to come stand on this side. Yeah, very good. All right. I'm going to make a space shuttle stack. All right. Put it together. One of these straws is going to be our orbiter. One is going to be our external fuel tank, and one is going to serve as both of our external fuel tanks. I'm going to put it on our pad. Come on. There we go. All right. What we're going to do is I'm going to lift up this plunger. I want you to hold it up here. We're going to do another countdown to blast off. 5, 4, 3, 2, 1, blast off. When I do it, you just got to let go. Not going to put any force behind it. Just let go. All right, we're going to see if we can launch our space shuttle stack. In order to do that, I'm going to stand back here so it doesn't hit me in the head. All right. 5, 4, 3, 2, 1. Blast off. Yay! We have got off our launch pad. High five. Very good. You can go out and sit down in your seats. Give them a round of applause, my friends. Can I have another volunteer? Yeah, back there. Bright sweatshirt. Come on up. Now we are 2 minutes after lunch. Those solid rocket boosters have burned out. We've got just our orbiter and our external fuel engine. Come on, stand right over here. All right, I'm going to put our stack back on our launch pad. Push this up, hold it right there. Once again, we're going to give you a countdown to launch. When we get to 0, just let it go. All right, 5, 4, 3, 2, 1. Very good. One a little higher. Very good. Good job. Can you get my? Oh, okay. Got it. Thank you. All right. Now, after our solid rocket boosters are dropped, it only takes 8 minutes after launch for that external fuel tank to run out of fuel, and that is dropped as well. The external fuel tank actually burns up in our atmosphere. It's the only part of the space shuttle stack that's not reusable. And to show this, I'm going to need one more volunteer. One more volunteer. My friend in the front, come on up. going to count down from 5, 4, 3, 2, 1. Blast off. I'm just going to drop it. And we're going to see where it goes. All right. 5, 4, 3, 2, 1. Blast off. Oh, very good. Give our friend a round of applause. Pick up my rocket. Thank you. So, if you've been watching, you've seen that every time that we dropped a piece of our space shuttle, our space shuttle stack was able to be launched higher and higher and higher, which is exactly why during the launch itself they dropped these pieces in order so that our rocket can go higher, same amount of fuel. All right.
Run up there right quick and
Now, once our space shuttle is in space, it has to orbit Earth. Now, to orbit Earth, you've got to go around it. You've got to go a very specific speed. You go too fast, you shoot out of orbit. You go too slow, you come back through the atmosphere into Earth. You have to go exactly 17,500 miles per hour. At the point that our space shuttle has dropped its fuel tanks, our orbiter is going 17,000 miles per hour. Needs an extra 500 miles per hour to go. That's where our last system, one of our last systems come into play. Right over here and right over here. On our space shuttle, they'd be right on top of you. Unfortunately, our space shuttle is covered by the tail cone. It's called the orbital maneuvering system. And inside the orbital maneuvering system, there's a special kind of fuel called hypergolic fuel. This fuel has a fuel and an oxidant. The fuel is called monomethylhydrazine, and the oxidant is called dinitrogen tetroxide.
that only has one.
These chemicals are kept in separate containers because when they combine, you get
Two nitrogens.
a very scary chemical equation and spontaneous combustion. When these two chemicals meet, they explode, which is great for when you are in space because then you don't need to carry an ignition source with you. You don't want something sparking inside your shuttle during liftoff. So when they need to get that extra 500 miles per hour, they engage this system. Now also when they are orbiting around Earth, they might need to get into a specific position, either to dock with the International Space Station or maybe fix the Hubble Space Telescope. And in order to do this, they have a system called the reactionary control system. And this system is noticeable on our space shuttle by all these little circles that you can see all over the shuttle. If you look right over your heads, you see one pair of those circles right there. This system also has packs of hypergolic fuel that help our space shuttle move. If you want our space shuttle to move to the left, you would shoot out a reaction of hypergolic fuel to the right. If you wanted the space shuttle to move down, you'd shoot out one of those packs of hypergolic fuel from the top of the nose in order to point it down. Remember, for every action, there is an equal and opposite reaction, even in space. Once the space shuttle crew has used these last parts of fuel in order to get the space shuttle in position, they have no fuel left. None. And they still have to get back down to Earth. And so that's where our Enterprise comes back into play. You see the Enterprise tested, landing on a space shuttle, landing on a runway without any fuel. And that is how every space shuttle landed, from Enterprise to our very last space shuttle, the Atlantis, in 2011. Now, our space shuttle program isn't continued. It ended in 2011. So why are we still talking about this? Well, NASA wants to go to Mars. And in order to get there, they are building on the knowledge that they perfected during the space launch program. This is an image of the solid rocket boosters that are being tested right now for the Space Launch System, which is the system that will hopefully get us to Mars and even farther out in our solar system. Thank you very much. I hope you've enjoyed our presentation and your time on board our Intrepid Seer and Space Museum. If you have any questions, please come up and ask me, and have a wonderful